Today we're going to talk about Multus, an open source project that allows you to connect your Kubernetes nodes to multiple networks. This is extremely useful when you have a pod that needs to communicate on the internal Kubernetes network, as well as another network like another VLAN to communicate with devices directly. Now, Multus is something that I've heard of before in the past, but I really didn't have a use case for it, or at least I didn't think I did. Turns out that once I started hosting more inside of Kubernetes, I started to realize some of the shortcomings of the Kubernetes network. Home Assistant is the perfect use case to demonstrate some of the shortcomings of Kubernetes networking and how Multus can help us out in this scenario. But getting here wasn't that easy. This took me on a quest from Discord to Twitter to another Discord to GitHub to YouTube and then all the way back to my cluster to finally understand how this works. Today we're going to cover getting Multus installed and configured in our Kubernetes cluster so we can assign an IP from a different VLAN to one of those pods. Now, I know I just probably said a mouthful of jargon to those that don't understand Kubernetes. So we're going to cover Kubernetes networking and some Kubernetes basics to kind of get you up to speed so then we can get Multus installed. Even if you don't have a Kubernetes cluster or know what Multus is or know how Kubernetes networking works, we're going to cover this piece by piece and you can either follow along or just sit back and listen while we dive into Kubernetes networking, get Multus installed, and assign IPs to pods so that we can have those pods communicate on different networks. So we have a lot to unpack today between documentation, diagrams, CLI commands in a terminal. So let's hop right in. So as I mentioned, Multus is a container network interface or a CNI plugin for Kubernetes that enables attaching multiple network interfaces to pods. Typically in Kubernetes, each pod only has one interface apart from the loopback. But with Multus, you can create multi-home pods that have multiple interfaces. This is accomplished by Multus acting as a meta plugin, a CNI plugin that can call multiple other CNI plugins. Now, that's a mouthful if you've never done any Kubernetes networking. What is a CNI and why are they important? Well, CNI stands for a Container Network Interface, and this is pretty cool. So within Kubernetes, networks are pluggable. You can choose a CNI or a network provider inside of your Kubernetes cluster that will provide network communication and plus some other enhancements. Different distributions of Kubernetes choose different CNIs. Now you may have heard of some of these CNIs like Flannel, Calico, Cilium, Canal, and all of these CNIs plug right into Kubernetes and you can swap them out with a little bit of work. But a lot of distributions choose their CNI to ship with their Kubernetes distribution. So that gives you your network within Kubernetes. Now, if you've ever looked at your IP addresses within Kubernetes, you may have noticed that they have an IP address that isn't local to your network. And if you've ever tried to ping those pods or communicate with those pods, you can't. That's because Kubernetes uses an overlay network. So think of an overlay network like a network within a network. So a totally encapsulated network within the same network. And the way that these are encapsulated and communicate with other pods depends on the CNI that you choose. Like I mentioned, we have Flannel here, we have Calico here, we have Cilium here, and all of them choose to do things a little bit different. So I'll explain how Flannel works because it's a little bit easier to grasp. So if you look at these two machines, you can see that each of them have a network adapter. This one has eth0 and this one also has eth0. And they have an IP address from the network that they're on. So this one's 192.168.0.200 and this one is .100. And so these devices can obviously communicate with each other. But the Kubernetes cluster running inside of this machine has built an overlay network based on Flannel. And so you can see here that the way that it communicates is it communicates over a Flannel network ID, over the Flannel network to container networking. And then we have two virtual network adapters that attach to this pod. So a pod is just a group of containers. A lot of times there's only one container in the pod, but here you can see this has two containers. So this is a good illustration. And the same here. So if this backend service or this pod right here, or this specific container wants to talk to the web front end pod that's here, this service, or this specific container, here's how it gets there. So this container will first traverse this virtual Ethernet adapter to get outside of the pod, which attaches it to container networking for this group of services. Then it attaches to a flannel network based on the ID. Then it communicates with this adapter on the machine, which this is all encapsulated, and this packet can be sent to the other machine, which has an IP address assigned to this adapter, which then will determine which flannel network it's on by ID. This container network with this service knows that this specific container lives inside of this pod, and so it will forward the packet to there, attaching to the virtual Ethernet adapter to the pod, and then send it to the specific container. Now we know this is a lot to take in, but a lot of this isn't new. We just have some extra terms like pods and containers. And outside of this, it looks pretty familiar like traditional networking. And now maybe you kind of understand what the problem is that Multus is trying to solve. If not, I'll show you. Let's say, for instance, your backend service needed to communicate with a device on the network directly. Let's just say it's this application right here, but it's on the physical network. But let's say this is on the physical network. Well, this pod can actually traverse this network and communicate with it directly. And the return trip should happen as well. But what happens if this service wants to communicate with this pod directly? Well, then there's also a solve for that, which is create a load balancer and then have this service communicate with this load balancer, which then will route the traffic back to this pod. But what happens if this pod needs to do something really specific like broadcast or discover other devices on the physical network? Well, this pod, as you can see, is on container networking. So if it broadcasts to all of these devices and tries to discover devices there, these devices don't really have a way to communicate back. And so is the case with something I use called Home Assistant. So Home Assistant sits back here and it needs to communicate or discover, say, other IoT devices on this network. And so when this does a broadcast out here to try to discover these devices have no idea how to get back to this pod. And this is where Multus comes in. So with Multus, we can actually plug this in to our CNI and give this pod itself an external IP as if it was sitting on the same network as everything else. So the way to kind of think about this is that your pod actually ends up logically looking like this, even though it lives inside of Kubernetes. So now we get all of the benefits of traditional networking that we can with other devices that are on this network, but this is still living inside Kubernetes. Not only that, this pod can still communicate on the Kubernetes network or on the CNI that it was natively on before. And to simplify this a little bit, think of this pod right here as Home Assistant. On one side, it's still communicating with the Kubernetes network. It can still do pod-to-pod communication, and it can still get the liveness and readiness probes from the Kubernetes API, so no change there. But what it does change is everything on this side, which is we can attach this pod to multiple networks. So in this example, this could be, VLAN 1, this could be VLAN 2, and you can add more and more network adapters to that pod. So this is some pretty cool stuff. So you might be wondering, okay, that's nice, but how do we get this working? The way we're going to get this working is like this. Let's say we have 3 machines, and on all 3 of these machines, we have a network attached to it. And for the sake of argument, let's just say that they're on VLAN 60. And as we talked about, these Kubernetes nodes are all going to have their own container networking. And let's say that's 10.42.0.0 something rather. And then let's say within this Kubernetes cluster, we want to run some services. But then over here in this network, we have some IoT devices or some devices we want to discover. And for the sake of argument, let's say they're all on VLAN 20. So what we're going to end up doing is add additional NICs to all of these servers, and we're going to put them also on VLAN 20 so that we can then use Multus to give this service an IP on VLAN 20, which will allow us to communicate with these devices over here. And that's exactly what we're going to do, but Multus has a few modes that can be configured, so let's cover those really quick, just in case you need to use another one of these modes. So Multus can work in bridge mode, as you can see here, which can bridge multiple pods on the same host. We don't want to do that one. Or we can use host device, which seems pretty complicated because it is, but it makes a physical host interface move to a pod network namespace. And so what I think this does is push these network settings down to these virtual Ethernet adapters so that they can use stuff like DHCP to get an IP address from a daemon that runs on that node, or I think from external DHCP too. Even though this is kind of complicated, this is also a pretty common way to run Multus too, but we're not going to use that. Next up is IPVLAN, which we're going to use, but to understand IPVLAN, we should probably talk about the more popular mac-vlan. So mac-vlan is more like traditional networking where it will push a MAC address to the pod. So each of these pods have a MAC address, so then each of those can get routed accordingly and have an IP address from the host network that they're on. And this is what most people want to use if they're doing what I did, because each pod gets a unique MAC address. Now, IPVLAN is very similar, but they say to use this in cloud providers just in case there's security to enforce devices with multiple MAC addresses. And this will get around it by sharing the MAC address from the host. As you can see, it pushes it down to there. Now, I could probably switch to mac-vlan in my environment, but I have it working with IPVLAN, and it's simple to swap out, as you'll see. Now, before we install Multus, I'm just going to show you really quick how my machines are configured with this additional NIC. So as you can see on all of my workers, I've added an additional NIC. So I have net 0 and net 1. And so net 0, remember, that's the default network that my CNI is going to live on, and the original NIC that I can communicate with this node, that's on my VLAN 60. So this will be an IP address like 192.168.60.52 or something like that. But then I added an additional NIC here, and you can see here, and I set it to VLAN 20, and that's my IoT VLAN. Then I added these NICs to all of my workers. You can see I have net 1 with VLAN 20 on 1. If we go to worker 2, you can see I have net 1, VLAN 20 on worker 2. And the same goes for 3. I have net 1 with VLAN 20 on worker 3. And this is so that pod can really live anywhere on these workers, and when it comes up, it'll be able to attach to that network still. And this helps out so I don't have to have a dedicated node just for that VLAN. This pod can now spin up on any one of these nodes and attach the network with this network adapter. Now, there are a couple of gotchas with this NIC. I would consider assigning an IP address to all of these NICs. Now, there's a more advanced way where you could not assign an IP address to these NICs and let it be a trunk port, and then let multiple VLANs use that NIC to communicate with multiple networks. But there's a lot of gotchas. So I'll put some of that in my documentation in case you're interested in. I think that's the way I'm going to go. But for now, the easiest way is to add one NIC for each new network you want to attach to, and then assign that NIC an IP address. And if you're using Cloud Init, make sure that you configure Cloud Init appropriately, because Cloud Init configures your NICs when they start. It's a lot. But these are the things I had to work through over the last couple of days. So if you set a static IP, make sure that you set it in your Cloud Init. If you're not using Cloud Init, don't worry about it. Or if you're using DHCP, make sure it's on DHCP. But make sure that these NICs are assigned an IP address when they start up. So let's SSH into one of these workers just to see that happening. So I'm inside of one of the workers here. I can do an IPA, and you're going to see a lot of networking. This is for my Celium CNIs. You can see it creates a lot of adapters. So we can see ETH0, which is my primary adapter, which is attached to my VLAN 60. And then we can see this additional adapter that we added. It's ETH1 that's attached to my VLAN 20. Remember, your ETH1 or your second adapter is the one that we just added, and it's to target the network that we want this pod to also to be able to communicate on. So you should check all of your worker nodes to make sure that they all have this additional Ethernet adapter, and that they are all named the same, and that they all have an IP address. obviously not the same one, but just an IP address on that subnet. And I have documentation for all of this on my documentation site, and I'll probably include the more advanced way to do it without assigning an IP address there if you want some more pain. So now that we understand Kubernetes networking a little bit better, and we understand what Multus does, and we kind of understand what we want to do, now we need to get Multus installed. Now, this can be easy or very hard depending on the Kubernetes distribution that you're using. I say that because some distributions like RKE2 or even K3s have plugins available that you can just enable to have Multus working, which is pretty cool. And for me, since I provisioned my downstream cluster from Rancher and chose RKE2, they also have an option in here that you can choose your CNI. Here, I ended up choosing Multus and Cilium. You can see different options here. You have Multus and Canal, Multus and Cilium, Multus and Calico, or just the base CNIs if you want. But I simply just had to choose Multus and Cilium, provision this cluster, and then modify the Helm config, which you can either find here on one of the nodes, or just deploy this Helm chart config that modifies this Cilium chart to say, hey, we are not exclusive, we're going to have more CNIs. But if you're doing this all from scratch, which is perfectly fine, you can follow the installation guide that they have, and it's as simple as applying the YAML file and a couple of things you want with the plugins, and you should be good to go. So to check to see if it is installed, let's do a kube control, get all pods, all namespaces, and we're going to grep for Multus. And as you can see here, I have the RKE2 Multus. Next, we need to create a network attachment definition. So this is a definition for this network that we want to attach to the pod. You could have multiple of these, you could just have one, but it's somewhere we're going to put this configuration in the cluster so we can reference it from a pod. So for example, I'm just considering this network attachment definition my IoT network. So I've called it Multus IoT. In this config, I'm setting the CNI version, which 0.3.1 is the latest at the time of recording this, so that's what I'm choosing. Then we set our type. Now I'm setting IP-VLAN as I mentioned. You can probably go with mac-vlan. I'll probably end up changing this, but you'll want to set it to mac-vlan or IP-VLAN depending on whether your cloud hosting provider allows this or not. I think IP-VLAN is the safer way, but mac-vlan is the more popular way. Then we're going to set the NIC. They call this master, but really this is the NIC that we just configured that it will kind of clone into a virtual adapter, and it'll use that adapter. Really, it's just a pointer to say which NIC are we going to point to for this network. And that's ETH1 according to what we just saw in the terminal. Now, yours might not be ETH1, may or may not be. You'll want this to basically match what we found to be as your second adapter on the worker nodes. If they're mismatched, I have no idea what to do. Make them the same. Okay, then we're setting some IPAM settings. So these are IP address management settings. There are lots of different settings you can choose here too. We can use things like DHCP, which we talked about a little bit earlier, where you can run a daemon on that host to assign IP addresses to it. You can use host local, which maintains a local database of IP addresses, or you can do what we're going to do and assign a static IP address to it. Oh, and then there's whereabouts, which I've never used, but this assigns an IP address cluster-wide, which is kind of what we're going to do with static. I'll have to look into whereabouts more. But for our IPAM, we're going to set it to static. Then we're going to set up some routes. So in my cluster, I'm telling it, hey, to get anywhere on the 192.168 network, you're going to have to go to your gateway to get there. And what's the gateway for that NIC? Well, for me, it's 192.168.20.1. So this should be the gateway for this network or this NIC, right? So for me, this NIC is assigned 192.168.20.70. So its gateway is 192.168.20.1. Okay, and there are probably 1,000 more configurations that you can apply to this that I've tried over the last couple of days, and so I finally figured out what the minimum amount of configuration you need to configure this network is for Multus, and it's exactly this. Now there are some things we're going to configure in the pod here in a second, but let's apply this to Kubernetes now. So to apply this to Kubernetes, it's as simple as running kube control apply You might notice this is a K. It's because I use an alias because I type it so much. But kube control apply -f. -f means a file, and then I'm referencing this file that I have, that network attachment definition file. And so this is going to apply to my cluster. So let's apply it. Helps if I'm in the right folder. Then we'll apply it, and we can see it was applied. And to make sure it was applied, even though Kubernetes said it was just applied, we could do a K, get, network, attachments, and this Multus IoT, which is the name. So we're saying Kubernetes, get this thing, which is a network attachment definition, with the name Multus IoT. And you can see it's there. I just created it 23 seconds ago. If we want to see the contents of that, we do something very similar, but instead of saying get the thing, we say describe the thing. And if we describe this network attachment definition that's named Multus IoT, we can see the contents of it. And so this is the configuration that we just applied. So we're looking pretty good now. So creating this definition or defining this network within our Kubernetes cluster is half the equation. The other half of the equation is then telling the pod to use this network attachment definition or use this configuration. How do we do that? Well, we add annotations to the pod. Let's do that. So here's a really simple pod definition that I must have applied 1,000 times while I was figuring this all out, but it's the minimum I need to be able to test this to see if it'll work. We'll do some advanced stuff here in a second with Home Assistant, but this is a pod definition according to Kubernetes. So I'm creating a pod, I'm naming it sample pod, I'm putting it in the namespace of default, and then I'm setting an annotation, and this is exactly what I was talking about. So we're annotating something in this namespace, in the network namespace, and we're passing an annotation to it. And so I'm passing it an array, and in this array I have one object, and in this object I have a property called name, and that's pointing to that definition that we just created. Maybe it'll help if I split this over here. So I'm pointing it to Multus IoT, which is the name of that definition. I'm saying it's in the namespace of default, which this definition is in the namespace of default. Then I'm giving it a MAC address, and this is pretty cool. I figured this out. I'm actually assigning a MAC address to this pod. Now you might be asking, why the heck are you assigning a MAC address to this pod? Doesn't it get one automatically? Yes, it does. Lots of times. So if you're testing this out and you kill this pod and you start a new pod, it's going to generate another random MAC address. And you'll see this over and over in your DHCP. Now there's nothing wrong in your DHCP server if you see lots of machines now getting this IP address. But I wanted to kind of clean that up, so I passed a MAC address to it. And it also helps me track traffic for this machine within my firewall. Anyways, totally optional. I would suggest doing it so that you don't see a ton of cruft in your DHCP server all filled up with this IP to random MAC addresses. Anyways, then we assign IPs to it. Now you can assign multiple IPs because look, this is an array. I haven't used that feature yet, but I only want one IP. But since IPs is an array of strings, it looks like, I'm setting this first element to the IP address that I want in CIDR and CIDR. Do people say CIDR? I kind of like that. In CIDR notation, CIDR. So that CIDR notation I set as 192.168.20.202/24. So this is saying a subnet of 255.255.255.0, and I want the IP address of 202. And so here in the spec, this is typical Kubernetes stuff, but I'm saying, hey, we're going to have a container. The container is going to have a name. I named it sample pod again. It's going to be based off of Alpine, which is a tiny, tiny Linux distribution. So I'm saying the image is Alpine. It's obviously going to pull the latest. And then we're going to run this command, which is basically saying, hey, just sleep forever and then wait. So what this does is just make sure that the pod doesn't spin up and shut down right away, because if you didn't have this command, that's what it would do. It would execute the pod and would shut down. So this keeps the pod running so we can get into it and look at it. So let's do that. But before we get into this pod and kind of look around, we have to apply this pod. So how do we apply this pod? So this is going to create this pod within Kubernetes. So we're going to do a kube control, or k apply -f, again, a file, and we're pointing to this file that we were just talking about, samplepod.yaml. So if we create that, the sample pod got created. So let's do a K or kube control get pod sample pod. So this will get our sample pod, and as you can see, it's running right now. And then if we go to describe the pod with K describe pod sample pod, remember K is kube control. Now we'll see the annotations that we set as well as some annotations that Multus has set. Now if we scroll down a little bit more, we're looking for something in here, and this is exactly what we're looking for. So we're looking to see that, hey, at first an add interface was set to our CNI, or default interface or default network for pod communication. But then we see we added an interface of the IP address that we assigned. And so it's saying, hey, I got this from default Multus IoT. That's the definition of the network that we created. And then it assigned it to net1. So pretty awesome. But in case we don't trust what that description said, let's actually exec or shell into this pod, and let's go inside the pod and kind of inspect our environment. So how do we do that? Well, we do a kube control or a K or kubectl or kubectl, however you want to say it. I've always said kube control. The kube control exec-it. So we want to do this interactive. What are we going to exec into? Well, a pod called sample pod. And then we're passing it this argument of /bin/sh. So this is an Alpine image, so we don't have bash or anything like that. So we're just shelling in to the default of sh. So we're running sh once we get inside of there. So if we run sh, hey, we're inside of there. How do we know we're inside of there? Well, first let's run a top. What are the processes that are running? See, this is cool about containers. Well, we're running that bin ash, trapping it, and we're running sleep infinity. So pretty cool. These are the processes that are inside of that container. But that's not why we're here. We're here to see what does our networking look like. So let's run an IPA. If we look here, we can see our loopback address, which we expect. Then we can see net1, which is the new adapter that we attached. And we can see the IP address that we assigned to this pod. And if we see at 0, that's our default container networking here, 10.42.4.205. But really cool, now this pod has an IP on this VLAN. So let's get out of here. And just to check from my machine, let's see if we can ping that pod on that IP address. And as you can see, we can. So this is really awesome. This is exactly what we wanted to do. This pod now has an IP address on my IoT VLAN. But this pod, as you recall, isn't really doing anything interesting. So this was the contrived example. Now it's time to go to the real example, or the reason why I went down this whole rabbit hole to begin with. It's because I wanted Home Assistant to run in Kubernetes, but then have that pod have an IP address on my IoT network and still allow me to communicate with that, say, through my ingress controller. So let's do that. So here's what my Home Assistant deployment looks like. Now we'll really just focus on the important piece, and that's just the annotation. That's what's really cool, is that we can just set annotations now on our pods and tell them which network to join. So as you can see, we're setting Multus IoT again because we want to use this network definition that we have over here. We want to set the namespace to default. That's saying, hey, this definition is in the default namespace. And MAC address, again, this is optional, but if you use it, make sure it's a different MAC address than the one we used before. And then we're assigning an IP. It's an array, but we're only assigning one. So in this first element, we're assigning it a.201, and it's on the subnet of /24. So it's one lower than we had before. So if we want to apply this deployment, we would do it like we did the other one, but we're going to do a kube control or a k-apply-f for file. Then we're pointing it to the file we want to apply, which is my deployment YAML, which we were just looking at. If we hit enter, it's now requested the desired state to Kubernetes, and Kubernetes should be spinning this up. So if we do a k-describe deployment apps Home Assistant, so we're going to describe this deployment. Oh, that's delete. Don't want to do that. We actually want to describe this deployment to check on it. And if we check on it, we can see it's getting created right now. Then let's do a k-get pod Home Assistant just to check on it. and we can see it's ready and it's running. So let's do the same thing we did before. Let's exec into that pod or shell into it. And so instead of doing sample pod, we're going to choose the home assistant pod. And again, we're just going to pass an sh to it. So now we're inside of this pod. You can see we exec into /config. We do an ls, we can see all our home assistant configurations, but that's not why we're here. We do an IPA, you can see we also have a net1 with that same VLAN right here. So 192.168.20.201. So this means we're exposed on that IP. So let's ping it from the outside. Now I know that ping's not the greatest test to do, but let's curl that endpoint or use curl to determine if we can actually see the Home Assistant webpage. Let's do a curl on the IP address on the default port of 8123. And so that's where Home Assistant should be hosted. We do a curl there. Hey, we see a whole bunch of HTML. That's a good sign. So that means we can actually go here and see our installation, but that's not how we want to access it. Remember when I said we could still access this over our container network as well as the IoT network? Well, I have an ingress controller or traffic set up so I can have certificates and put a reverse proxy in front of this pod so I can get to it securely with certificates. And so the way that I do that is go to a Home Assistant DNS record that's pointing to my ingress controller, my reverse proxy, that then terminates to this pod. That's super complicated. But I go internally and I have secure certificates. I have a whole video on that if you want to see. But that gets me to Home Assistant. And as you can see, I'm actually accessing this from that ingress controller too. So that means now we're in this state right here where we have Home Assistant running in our cluster. It's attached to our container networking so it can communicate with everything else. But then we've also attached this NIC directly to the pod, which gives it an IP address that then can communicate with these devices. And to make things super clear, I'll just put our IP address right here, 20.201. So this is our IP address that we just assigned to this pod. And now we can communicate with these devices. So let's try that within that pod. So if we exec into that pod, let's do a ping to 192.168.20.52. That's another device on the network, an IoT device. You can see I can ping it, but let's also do, say, a ping to 192.168.60.1. That's the gateway on another network, and we can do that. Then let's say do a ping to google.com to make sure I can ping out of it, and I can. Here's the other cool thing. Let's check our DNS within this pod. So let's do an NS lookup on google.com. We just did that, so we know it's going to work and resolve, and we get a response back. You can see it responded back from our internal DNS, which is then mapped to our host, but you could see who responded to that. Pretty cool. But what if we wanted to do an NS lookup for, say, another device on my network? Well, we would do an NS lookup for a device on my network by DNS name, and this is Kate's home worker 01. This is actually the machine that we're on, and then pointed to my local domain. If we look that up, hey, I did get a response, and I see what the machine is. Cool. So I have external DNS, I have my internal DNS working. Here's the other cool thing. We can actually check our container networking DNS. So I also run homepage, a homepage dashboard that I have a video on in my Kubernetes cluster. And for homepage, I created a service record. And that service record looks like this. It's called homepage. And if we do an NS lookup on homepage, we should get a response. And we do. We got a response from core DNS, and it shows the fully qualified domain name within this cluster. So it's homepage.default, that's the namespace, .service.cluster.local. Pretty cool. This means this is running great, and we can communicate inside the pod, outside the pod, within container networking, and do anything we want to do. And then the last thing we'll need to do, if you're following along with Home Assistant, is now tell Home Assistant to use that new network adapter as the default. So to do this, first you'll want to go into, I think, your profile. which I think is just click on yourself, and then you'll want to find advanced view. It's kind of hard for me to find, but here, you'll want to make sure that this is turned on so that you can then go into settings and then go into system, and then you can go into network and see all these options. And here, finally, this is what we want to see. We want to see this adapter net1. Now, by default, this is what it was set to. It was using container networking, and this was the whole problem with it being inside of a Kubernetes cluster, is that it couldn't broadcast and discover other devices because that response would never come back to it. But now, since we have an IP address on that network using traditional networking, we now can discover new devices. So you'll want to set this to the IP address that we just chose. And now Home Assistant will work as if it's not in a container. Sometimes I think virtual machines are so much easier to use. But I want to run Kubernetes, and this was a great learning experience. And speaking of learning experience, this was something that I wasn't even going to make a video on, but I decided that I learned too much not to share this with all of you. And I got a lot of help from a lot of people. Huge shout out to Andy on Twitter, who, unbeknownst to me, actually works for Rancher and helped me out and even created a video. Thank you for that. Other folks on Twitter who chimed into my thread about this and could see how much I was struggling with this. And also a huge help to everyone in my Discord for helping out, along with everyone in the Home Ops Discord for helping out too. Devin, thanks for your help. I appreciate it. Huge thank you to everyone. And since everyone helped me, I decided it was my turn to help you all back and create this video. So I learned a ton about Kubernetes networking. I learned a ton about Multus, maybe too much, and I hope you learned something too. And remember, if you found anything in this video helpful, don't forget to like and subscribe. Thanks for watching.